Hi guys. So most of you probably know or at least heard about SimHub. And I did as well, but up to until just a few weeks ago, I literally had no idea how really amazing and powerful it is. And it's all thanks to my friend, Brian Young, who opened my eyes to the Arduino tab in this application. And so here is my very first SimHub dashboard, which I simply called Display 1. It includes a 2004 LCD screen, 1.8-inch gear indicator, REV LEDs, and a few buttons here. So I can use these buttons, for example, to switch through different screens on the LCD. But at the same time, they can be mapped to any game functions, depending on your needs. As you can see, I wrapped it in carbon fiber vinyl, so it's definitely not perfect because I really suck at doing this. But still, I think it looks pretty alright, and I quite like it, to be honest. Right, so on the left side, we have a USB port for the Arduino. On the right hand, there's nothing, same on bottom and top. But on the back, there's a cutout for the USB cable to connect it inside the box with the Arduino. That's in case one would prefer to run it from the back of the screen. And also there's the cutout for controlling the LCD contrast. And actually this is something I need to show you. So let me just get a cable and connect it. Yeah. And the thing I want to show you is that I almost considered returning my unit because I thought it's faulty. And this is all because the contrast was set all the way down. So when it's all the way down, it basically is an empty screen. So yeah, I thought it's faulty, and realistically I just had to set the right contrasts. Yeah, silly little thing. Right, so the last thing are these two mounting screws for the two different mounting solutions that I designed for my display. And let me show you them right now. So the first one is supposed to be, at least, a universal monitor mount. Basically, the idea was that you lock the monitor between these two flat spaces and just lock it down to hold the whole unit in place underneath your screen, and the display can be moved up and down on these two rails. Unfortunately, it doesn't work that well. So first of all, the plastic itself doesn't hold the screen underneath the monitor. It just slips down. So I had to use these kind of like silicone gel pads that you use to like put the phone on your dashboard or something. So I put one larger one on the back and smaller one here on the front, and I sandwich the screen between the two. It kind of works, but feels a bit flimsy, to be honest. If you don't move the monitor, it's kind of fine, but overall I'm not particularly happy with this design. And if I were to put the dashboard under my monitor permanently, I would just use adhesive Velcro, like the one I have here. So something like that. And that has M3 underneath it. Just lock it in place. Simple and much less complicated than what I made here. The second mount, on the other hand, is a completely different story. So I took off the front cover of my Trustmaster wheelbase, modeled it in Fusion 360, and got this. Then I attached the vertical mount to it and added the same rails that were used with the monitor mount, just to hold the display on it. And I have to say, this actually works awesome. And I'm super happy about it because it holds the screen very well. It's stiff enough so you can still push the buttons, and it's just close enough to me so I can clearly see the screen. And overall, yeah, really recommend this approach. I have also made a light version that only has the screen and gear display. It's a bit smaller, but apart from that, it's basically the same design, and it's compatible with both the monitor and the wheelbase mounts. Okay, so next I'll show you the display in action. Then I'll jump into the connections diagram, and lastly I'll go over the SimHub setup, just in case you're not familiarized with it. Alright, the first step is to define what are the components of our SimHub display, and we need to generate the Arduino code. So in order to do that, we jump into the SimHub app, then we go into the Arduino tab, switch to My Hardware, and click on the Open Arduino Setup tool. What this will do is open a new window, which is called Sketch Setup. And in here we have a list of all compatible hardware that can just work kind of out of the box with SimHub. As I showed you before, the items we'll be using are, first of all, one 8-bit RGB LEDs. So this is the WS2812B. We will use one set of these LEDs, but there's a watch out here. The LED count here, the one that we selected in here, doesn't refer to the whole 8-bit section of LEDs. It literally means a single LED. So in order to use all 8 of them, we need to increase that to 8. Which caused me a lot of issues initially because I misunderstood this. Another thing, the ones I got and the ones that will be linked in the description, these are GRB, not the standard RGB. So the best way to test it is to switch on the testing mode. So basically what it does is all the LEDs should be highlighted red when you plug in the Arduino. What that means is, first of all, if it's not red, then it means you choose the wrong encoding options. And secondly, if not all of the LEDs light up, you didn't choose the right number in the first selector. Yep. In my case, with this setup I did, you also need to reverse the LEDs because that's how the design is set. Next, we have the 2004 I2C LCD. So we use one of these as well. First of all, you select the size. So this is 2004, the first one, so that's fine. Now the second one is I2C address. And this might be a bit confusing bit. So as far as I know, as far as my research goes, the most popular addresses that take place 9 out of 10 times are 0x3f, which is the default one, or 0x27. In my case, it was 0x27. Additionally, I had to use the PCF857-4T, not the DF robot. To be honest, I don't know what's the difference there. I don't even know how to specify which one of these is compatible. I just tried the default one, didn't work. Tried the other one, it worked. So yeah, I don't have the full knowledge there. One more thing with the address. If neither of the two I mentioned work for you, I'm afraid you'll have to Google for a specific Arduino sketch that allows you to get the I2C address of your 20x4 LCD. Last thing is just hello world as a starting option. There's no way to change the text, so that's irrelevant. Going forward, we have the buttons. So I will want to use 4 of them. So I do 1, 2, 3, 4. And on the side, you see automatically SimHub is assigning the pins that into which we should solder individual components. So in my case, per my setup, I'm using pins 7, 8, 9, and 10 for the 4 buttons. So let's just change that. 7, 8, 9, and 10. So we will use these pins to connect the buttons. And lastly, there's the 7-segment gear display. So this is going to be the 74HC595 gear display. So we need to enable that. And we have 3 pins that we'll have to connect. So that's fine. And that's basically the setup I'm using for my display. And now what you need to do is basically open that in Arduino and follow the standard practice, which is select the board you want, select the port, validate, verify, and upload to your Arduino. So now let's look at the connection diagram. Here you can see I have my Arduino Nano with all the pin connections as per SimHub. And then I have all of my remaining components, so the 4 buttons, the LED strip, and the I2C controller for the LCD display. The I2C controller has ground, 5 volts, SDA and SCL pins. So the ground and 5 volts go to 5 volts and ground on the Arduino, and SDA and SCL as per our setup in the SimHub. For the LEDs, again, you do 5 volts input, you do the ground. Potentially you could connect both grounds, but it works fine in my case with just one ground pin being connected to the Arduino. And lastly, you have the data pin, but you have to use the data in. So it's the data controlling the LEDs coming from Arduino into the LEDs. Data out simply won't work. Then we have the 4 switches that are connected to individual pins, and then the other side connects together and to the ground pin again. So that's fairly straightforward. But now the 7-segment LED is a bit more complicated. So let me guide you through that, because I had some issues trying to figure it out. First of all, there are several different types of the 7-segment LEDs. By default, majority of them is this one, so 5161AS. and they have the following pins. So on the back of the 7-segment display, you have 10 pins, 1 to 5 on the bottom, 6 to 10 on the top. And majority of these displays have pin number 1 to be segment E, then D, then you have the common cathode, which you have to connect to the ground. Then you have segment C. DP stands for decimal point, so it's this dot here, but it's not being used by SimHub, so we don't connect that at all. Then we have BA, CC again, F and G. Now that's all great, but it completely doesn't work for the one I had. I bought this one, so FJS, whatever, I won't read it, you can see it on the screen. And it took me a while to find what is the correct pin layout in this segment. Wasn't that quick and easy, but fortunately I found it eventually. So you have common cathode on pins 1 and 5, which is completely different than in this case, and we also have the decimal point in the middle here. So when I connected this segment according to the standard layout, it was just showing some rubbish on the display. It was not highlighting the correct segments of the display. So check the description of the segment you have printed on your unit, and then follow the connection based on this screen. Now, if you have even something different, then don't worry, just type in the serial code of your display and add like a datasheet or something in your search criteria, and I'm sure you'll eventually find it somewhere. So that's these are the pins that we have for our segment, and then we have to connect it to the 74HC595 breakout board or the chip itself directly. So here's the connection diagrams depending on which option you choose. There's no fixed option here. In the box there's enough space for any of these options, so it's completely up to you. So if you buy the breakout board and you get the purple one or the red one, because these look a bit different, and if you look at the names of the pins, they're slightly different as well, but the layout is exactly the same, so the connection logic is precisely the same between the two. If you choose these, then SER in, or basically the pin on top left corner, is your data, so you connect that to the data pin as per SimHub setup. Then the second one is latch, and the third one is clock. The next step is that both the OE pin has to be connected to ground, and the SR clear has to be connected to VCC. So in the case of the red board, this is the reset pin. And then this breakout board has to be connected to the ground and 5 volts of the Arduino board. Then we have to connect our 7-segment LED to the board, and we choose one of the common cathode pins, connect them to the ground, and then each segment of the display, as you can see them here listed, so it's A, B, C, D, E, F, and G. So like the segment A, if we look up, segment A is pin 7 on both types of the display. So we connect pin 7 into pin H on the breakout board. Now, there's one downside in the whole setup, is that you have to, and I really mean it, you have to use the at least 220 ohms resistors for each of these segments. And I have to admit, I did it initially without these resistors, but then again, huge thanks to Brian. He pointed out that basically I can kill the display or kill the board if I don't use them, and it's basically a very bad idea not using the resistors. On top of that, the display was extremely bright, so and there's literally no control on the brightness of these, so it was unusable. So yeah, it's a bit of a pain. You have to use those resistors, but yeah, it's just they're super cheap and it's pretty easy to connect them. So you just follow the diagram here, and that's it basically. It's all about the wiring and putting it all together. It's actually the same logic applies to the chip itself. It's just sorry, you connect slightly different pins. So you have pins 16 and 10 have to be connected together, and then to the Arduino 5 volts. Pin 14 is data, 12 is latch, 11 is clock, and then you have pins 13 and 8 connected to the ground in Arduino. And then you also have the individual pins of the 7-segment display. I hope it's all clear. I guess it's fairly straightforward. If you have any questions, just drop a comment and I'll try to help out. Alright, so hopefully you have it all connected. Everything's working just fine. And now it's time to set it all up in the SimHub. The first step is to obviously open the application and go to the Arduino tab. In here we will do a bunch of changes to tweak the display to our needs. First of all, we go to My Hardware and verify the Arduino we're using is recognized here. So you can see it has, mine is called PMT Display 1. So the SimHub automatically identified it. So on our display we have 4 different features. There's the 7-segment display, the LCD, ref LEDs, and the 4 buttons. So the thing that we can customize in SimHub is mainly the LEDs and the LCD. The 7-segment display cannot be tweaked at all. By default, it will always just display the gear of the car we're driving. And the buttons are simply recognized as a gamepad, game controller buttons, so you can map them to anything you want. So let's look first into setting up the LEDs. We go into the RGB LEDs tab here, and we have a bunch of options to set the ranges of how the LEDs light up. So I have it set to RPMs 15% to 50% in the first range of colors, and then 50% to 95 for the second one. The reason why I have it in 2 ranges is because you can use only the combination of 2 when you want to use the gradient. And if you don't have this effect by default, what you do, you click on Add Effect. And on the list here, you have different options that you can use the LEDs for. The ones I'm using are the RPMs, show LEDs gradient based on car RPMs. So that's the one I'm using right now. And I have it set to go from green to yellow for the LEDs from first one till 4th. So remember, we have 8 LEDs in total. From the first one to the 4th, it will go from green to yellow. It will show the percentage of from 15% of total RPM of the car we are using till 50%. And then the second range is from starting position is LED number 5. So this one was up to number 4. So we're starting from 5. And again, it's going to be the 5th, 6th, 7th, and 8th LED. So 4 in total. And we start from 50% and we end up 95. The reason I set it to 95 is because if I had it to 100%, the last LED basically wouldn't switch on, because that's basically just maxing up the refs, and I was realistically using just 7 LEDs. Yeah, so when we have it all set up, obviously you can change the colors the way you want them. There's a bunch of options here, or modify the ranges, etc. Just to test it, you click on Open Test Data Editor, and we get a window like that, and you simply use the slider to look how the refs increase and the corresponding LEDs should light up if everything is working fine. If not, check your connections, verify it's all done as per the diagram I showed you before, and then just try different options, re-uploading the code until it's working, because your LEDs might, for example, have a different setup. Okay, last thing we need to set in here is to check, switch the brightness to the level we want. I have it on 35%. That seems to be an optimum for me. This is just, you tweak it to your own needs. Now, the second thing I want to talk about is the LCD screen. So this is a bit more complicated, kinda. We can set different screens that will be displayed on the LCD. We have an idle screen, so basically that's the one you can see right now. I have my GPU, CPU utilization, the temperatures, and the current time. And yes, it's half past 1 a.m. right now, because clearly I have nothing better to do than just record these videos. So in order to show you the example how to set up these screens, let me just create a new screen, temporary. I'll call it test screen. So we'll be setting up the display layout for the display module 1. As you can see, there are like up to 20 modules, but these are modules connected to the same Arduino, so you can have just multiple screens connected at once. But we only have one, so no problem there. So select the screen, and also the first thing I would suggest you to do is change the preview. So here you have the segment view. So if I, for example, added a text, XXX, you see it's displaying it's applying the preview as per the segment displays. But we have an LCD, so we use the drop down just to show the LCD. So it's actually showing us the setup that we will actually see on the screen. I can also change it to be idle screen or in-game or both, depending on what I want. And then I can add my text. If I want to switch to the next line, I add another element on the list, and this particular element should be line return. And then when I add further elements, let's say I'll call it time and colon. Yeah, so that's how it's displayed. And then I add another one element again, but this time I wanted to display my my PC clock. And now we select the SimHub property and pick the current time. So it's just current, I think it was date time. Yeah, so you search for the one you want, double click, and as you can see, it's displaying the date and the time. You can modify the format, so you can set it, for example, just to like a microseconds as well, or you just manually amend the format depending on your needs. Yeah, and that's kind of it when it comes to the setup. If you want to learn what you can bring onto the display, you can just simply scroll down through the list of all of the variables available in SimHub, and just simply choose the ones you want. The names are very straightforward, so you will have no issues understanding what each one is doing. If we go back to my main screen that you keep seeing right now, I have my time, then I use the current date time, line return, CPU text, then I have my CPU load percentage, temperature, CPU temperature, etc. So that's how I set up my initial idle screen. And then, for example, if I look at my lap times screen, in here I want to see the lap times I'm doing in my game. So it's current lap time, previous, and best. And we have the current lap time variable, previous lap, new data, best lap time. So that's one I'm using during the game. Another one is tires. So here I have my temperature and wear of each tire, front, left, right, rear, left, right. and you simply have tire temperature front left, tire temperature front right, etc. It really is very straightforward once you do one or two screens. I actually made a mistake in this one, so that's the last one. I'm missing a percentage character, so let's fix that. Okay. So now let's set up a control to switch the screens. So I have three idle screens. So it's my core screen you see right now. I have like a PMT name, and then the test screen that we were just created. So we jump to the controls, and I can have set the buttons for show next screen and show previous screen. So I can change it. So it's just waiting for me to click the button, and if I just click that button, so that will be now my next screen, and I can change the other one and click the button again, and you can see now it's going to be the previous screen. So now if I hit the buttons, next one is my logo, so to say, and then we have our test screen that we just created. The button back, and I can switch between the screens. Obviously for idle, I usually just use the single screen, but in game you want to switch between the screens. You don't have to use the buttons connected to the Arduino. You can use any buttons on your wheel or like a button box or whatever, completely up to you. Hope that's clear. If you have any questions at all, feel free to ask them in the comments, because I did spend some time trying to figure it out. So, I made my own share of mistakes. So I'm happy to help you out with any problems you might be facing. Wow, that was a pretty long video, but if you manage to stick to the end, I have this box for the light version printed, and I won't be really using it. So if you'd like it and are ready to pay for the shipping costs, just send me an email. Okay, that's it. Thanks a lot for watching and have a great rest of the day. Bye.